These are the notes for Module I, Unit 2, Lesson 2. The topic is kinetic and potential energy. The essential question is, what are kinetic and potential energy? By the end of this lesson, you should be able to calculate kinetic and potential energy and know how these two types of energy are related. We've already learned about kinetic and potential energy, so hopefully you remember that kinetic energy is the energy of motion, and potential energy is the energy something has because of its height above the ground, its condition, maybe it's stretched out like a rubber band, or chemical composition. So the food we eat has chemical potential energy. In this lesson then, you've got just one learning target. Your focus is on the calculations. So the learning target is I can define and calculate kinetic and potential energy. The good news is that in this lesson, because we're solving for energy, there's just one label to remember. Every calculation you do today will be measured in joules. There are three vocab words today, and these should be familiar: kinetic energy, potential energy, and mechanical energy. So in the notes, you've got a table. Kinetic energy is the energy something has because it's moving. Kinetic energy depends on two things: the mass and the speed of the object. The bigger the object, so the more mass it has, or the faster it's moving, the more speed it has, the more kinetic energy it has. The equation that you use to solve for kinetic energy is 1/2 times the mass, m, times the speed, v squared. This one's a little bit tricky. The v actually stands for velocity, but in the practice problems, you'll be given a number for speed, and that's what you'll plug in for the letter v. To square a number, you multiply it by itself. So to put that into my calculator, I would square the number first, thinking back to order of operations, multiply it by itself, then multiply it by the mass, and then times 0.5. And we'll do some calculations practice in a minute here. Potential energy is the energy something has because of its position or condition. So potential energy comes in three forms: gravitational, elastic, and chemical potential energy. The equation we use is GPE, gravitational potential energy, is equal to mgh, where m is the mass, g is acceleration due to gravity, and h is the height. G, acceleration due to gravity, is always 9.8 meters per second squared on Earth's surface. So that is the number that you will always plug in for the letter G. And then underneath your table, you've got a couple notes to add. Mechanical energy is the sum of kinetic and potential energy. If you think back to earlier in Module H, you learned the law of conservation of energy. The idea that energy isn't created or destroyed, it's just transformed. It changes from one form to another. So in a situation like a roller coaster, mechanical energy is the total amount of energy in the roller coaster. At the top of the hill, before the roller coaster starts, it has a lot of potential energy because of how high up it is. It doesn't have kinetic energy because it's not moving. And then as the roller coaster goes down the hill, it gains kinetic energy as it picks up speed. It loses potential energy as it gets lower. So mechanical energy, the sum of those two things, is the same number the entire time. Then here you can see that I've substituted the formula for kinetic energy in for Ke, and here the formula for potential energy in for Pe. That is not something you'll be asked to do on the test or the quiz, but it is something that's modeled in your workbook, so I wanted to include that. And then again, like I said, we are only using the label joules today, in uppercase J, because we're calculating energy. So let's look at two practice problems. First, kinetic energy. Ke is equal to 1/2 mv squared, where m is the mass and v is the speed. So if the mass is 10 kilograms and the speed is 10 meters per second, let's calculate kinetic energy. So it would look like this. Ke equals 1/2 times the mass, 10 kilograms, times the speed, 10 meters per second, and that speed is squared. So Ke is equal to 1/2 times 10 kilograms times 100 meters squared per second squared. So if I multiply that across on my calculator, I put 1/2 in as 0.5. So I'm going to do 0.5 times 10 times 100. My final answer is 500, and the label is joules. Then let's practice calculating GPE, gravitational potential energy. So G, acceleration due to gravity, is always the same number, 9.8 meters per second squared. Mass in this example is 10 kilograms and the height is 15 meters. So this time I just plug the numbers in and multiply across. So we've got a mass of 10 kilograms times g, 9.8 meters per second squared, times a height of 15 meters, and that meters per second squared, that's already done. So I don't need to do any squaring in this equation. So 10 times 9.8 times 15 gives me a final answer of 1,470 joules of gravitational potential energy. Those are the notes for Module I, Unit 2, Lesson 2, and if you would like to see more examples of calculating kinetic or potential energy, I've got links to videos on YouTube for both of those on Schoology. So go ahead and check there.